Hello everyone, I am D. Harita. In this video we are going to learn about the implementation of DFS Traversal for a given graph. In the previous video we have learned about BFS graph traversal technique, and now we are going to learn about DFS depth first search graph traversal technique. Depth first search is an algorithm for traversing the graph data structures. This algorithm starts at selecting some arbitrary node as a root node of a graph, and it explores as far as possible along each branch before backtracking. To implement the DFS traversal technique, we use stack data structure. Here are the steps for implementing the DFS traversal technique. Step 1. Define a stack of size equal to the total number of vertices in the graph. Select any vertex as starting point for traversal. Visit that vertex and push it onto the stack. Visit any non-visited adjacent vertices of a vertex which is at the top of the stack and push it onto the stack. Repeat step 3 until there is no new vertex to be visited from the vertex which is at the top of the stack. When there is no new vertex to visit, then use backtracking and pop one vertex from the stack. Repeat steps 3, 4 and 5 until stack becomes empty. Consider the following example to perform the DFS traversal. Select any vertex as a starting point. Here selecting A as a starting point. Visit A and push A onto the stack. Visit any adjacent vertex of A which is non-visited. Here the adjacent vertices of A are B, D and E. Among the three vertices, selecting B. So visit B and push B onto the stack. Now B is on the top of the stack. Visit any adjacent vertex of B which is non-visited. Visit C and push C onto the stack. Now visit any adjacent vertex of C which is not visited. Visit E and push E onto the stack. Visit any adjacent vertex of E which is not visited. Here visiting D and push D onto the stack. Now D is on the top of this stack and there is no new vertex from the D to be visited. So use backtracking, pop D from the stack. After popping D from the stack, E is on the top of the stack. So visit any adjacent vertex of E which is not visited. Here F is not visited. Visit F and push F onto the stack. Visit any adjacent vertex of F which is not visited. Here G is not visited. Visit G and push G onto the stack. Now G is on the top of the stack and there is no new vertex to be visited from G. So use backtrack, pop G from the stack. Now F is on the top of the stack and there is no new vertex to be visited from F. So use backtrack and pop F from the stack. Now E is on the top of the stack and there is no new vertex to be visited from E. So use backtrack and pop E from the stack. Now C is on the top of the stack and there is no new vertex to be visited from C. So pop C from the stack. Similarly, there is no new vertex to be visited from B. So pop B from the stack. Now A is on the top of the stack and there is no new vertex to be visited from A. So use backtrack and pop A from the stack. Now the stack becomes empty. So stop the DFS traversal. Here is the pseudocode for DFS graph traversal technique. G is a graph and S is a source vertex. Let capital S be a stack. First, push the source vertex small s into the stack S, that is S dot push of S, and mark the source vertex small s as visited. While stack S is not empty, storing the top value in V, that is V equal to S dot top, and deleting the top element S dot pop. For all the neighbors of V here, which is W in the graph G, that is if the W which is a neighbor of V is not visited, visit that particular W, push it onto the stack. So S dot push of W, and now mark W as visited. Repeat this process until the stack becomes empty. Here is a program for implementation of DFS graph traversal. Enter number of vertices m, enter number of edges m, give an initial vertex v, mark it as visited. So visited of v equal to 1, and if j is not visited, visit it and push it onto the stack. That is, if visited of j not equal to 1 and visit of j is also not equal to 1, visit of j equal to 1, stack of top equal to j. Visiting j and pushing it onto the stack, top plus plus. Now storing the top value of stack into v and popping that particular top element from the stack. Now print v and repeat this process until all the vertices of the graph are visited. Here is the output. We are going to get enter number of vertices. Here I am giving it as 5 and number of edges as 10, and the edges are given as 1, 2, 1, 3, 1, 4 and so on. Enter initial vertex. Here I am giving the initial vertex as 3. Then it will be displaying the order of visited vertices, that is 3, 1, 2, 4 and 5. So this is regarding the implementation of DFS graph traversal technique. Thank you.